Hello, welcome back to Dnaofbioscience. So today's topic is about the chloride shift. So we know that the carbon dioxide in gaseous form diffuses from the cells to the capillaries, where it is transported in three different ways. First, it is in the dissolved form, then it is in the bicarbonate state, and third, it is in the carbonyl hemoglobin state. Okay. So first we'll discuss in the dissolved state. So in the dissolved state, due to high solubility, about 10% carbon dioxide gets dissolved in the blood plasma and it carried to the lungs. Okay. Next, in the bicarbonate state, the dissolved carbon dioxide in the blood, these are the RBCs. So this dissolved carbon dioxide reacts with water to form the carbonic acid H2CO3, and it occurs very rapidly inside the RBCs because of an enzyme called carbonic anhydrase. Okay, so because of the enzyme carbonic anhydrase, the formation of carbonic acid takes place after the carbon dioxide reacts with water. Okay, so about 70% of carbon dioxide received by blood from the tissues entered the RBCs, where it reacts with water to form the carbonic acid. Okay, so almost as rapidly as formed, all carbonic acid of RBCs dissociate into H plus and bicarbonate ions. So the most of bicarbonate ions formed within the RBCs then diffuse out into the blood, okay, plasma along the concentration gradient. Okay, so here comes about the chloride shift. So the chloride shift is nothing but the exit of bicarbonate ions considerably change ionic balance between the plasma and the RBCs, right? So to restore this ionic balance, the chloride ions diffuse from the plasma into the erythrocytes. Okay, so to balance this, the chloride ion gets inserted into the RBCs. Okay, so this movement of chloride ions is called the chloride shift, or it is also called as Hamburger principle. Okay, so this one is in the dissolved state and this is in the form of bicarbonate. The third step is as carbaminohemoglobin. Okay, so in addition to reacting with water, carbon dioxide also reacts directly with amine radicals. Okay, amine radicals means the NH2 of hemoglobin to form an unstable compound called carbaminohemoglobin. So the reduced hemoglobin, that is NH2 plus carbon dioxide, it will form carbaminohemoglobin, that is hemoglobin NH so reaction is NH2 plus carbon dioxide, hemoglobin NHCOOH plus H plus. Okay, so a small amount of carbon dioxide also reacts in this way with the plasma proteins. Okay, so about 23% carbon dioxide is transported in combination with hemoglobin and plasma proteins. Okay, So you need to remember three things. First, the carbon dioxide is transported first in the dissolved state, that is 10% carbon dioxide from tissues to the plasma. It is in the dissolved state. Then it carried in solution to the lungs. Right. The next, it's in the form of carbonic acid. So the carbon dioxide reacts with water to form the carbonic acid, and by the help of carbonic anhydride this reaction accelerates and the carbonic acid dissociates into H plus and bicarbonate ions, where the bicarbonate ions found within the RBCs diffuse out into the blood plasma along the concentrated gradient. And to restore this ionic balance, the chloride diffuses from the plasma to the RBCs, and this is called the chloride shift, or called as the Hamburger's phenomenon. Okay, and in the third step, as carbaminohemoglobin, so in addition to water, carbon dioxide combined with hemoglobin and binds with the amine radicals to form an unstable compound called carbaminohemoglobin. So this is all about the chloride shift, which is also called as Hamburger's phenomenon. If you like this video, hit the like button, share with your friends, and do not forget to subscribe to this channel. Thank you.